Hey there, algebra students. This is Mr. Zacek. We're in 6.4, word problems involving linear systems. Okay, now remember systems, we're talking more than one. So we should have, two variables, two equations, two variables. Could be more than that, it could be three, but in this we're just going to focus on two. To solve a word problem using two systems of equations, we're going to start with different variables, let statements. We're going to translate into two equations. Then we're going to solve the system either by substitution or addition, or remember, we call that also elimination. All right, so today we're going to be picking which one, and then we want to check both into that. So we got to define it. We got to have some equations, and then we have to solve. So we're going to do like 4 of these. We won't do them all, but we'll do 4. The first one, the sum of two numbers is 74. The larger is 4 more than the smaller. So we have a larger and a smaller. So let's let x equal the larger number, and let's let y equal the smaller number. Now, some of you, there actually is a way you could do this where everything is in terms of x, but I want to show you this in relationship to systems. So I'm not going to do that in this case. All right, now the sum. Let's start translating. The sum of two numbers is 74. Sum is the answer to addition. So we do x plus y equals 74. The larger is. Okay, now remember, is translates into equal. What's our larger one? That's x. So the larger is. X equals 4 more than the smaller number. Now remember, when more than, you always want to put it after more than and less than. Not as important with more than, but super important with less than. What's the smaller? Y plus 4. Now this equation, I look at how it's set up and I say, this is really set up for substitution. So I'm going to use substitution to solve this. How do I know that? Well, as I look at this second equation, what I see is I've got x isolated here. So that's isolated. So I got my x here. Where else do I have x? I'm going to replace that with this value right here. So as we go ahead and do that, I get y plus 4 plus y equals 74. Okay, sometimes my y's and 4's look alike, so I got to be careful. Now, I want to remove the grouping symbols. All right, in this case, there's only a 1 in front of it, so it's not going to change the value. Y plus 4 plus y equals 74. I'm going to combine like terms. 2y plus 4 equals 74. We're going to subtract 4. 2y equals 70. And I'm going to divide by 2. And y equals 30. Now, I've found what the smaller number was, but let's find the larger. The larger is x equals 30 plus 4. So x equals 34. And then the last thing I want to do is just put them into terms that we started with. So the larger number is 34. The smaller number is 30. Okay. So let's do number 2. Okay, one number is 15 more than the other number. The sum of twice the larger and 3 times the smaller is 185. So here again, we got a larger number and we have a smaller number. So let's let x equal the larger number. Let's let y equal the smaller number. You want to switch that up? You can do that, okay? But we need to define them. All right. So one number is 15 more than the other number? Well, obviously the larger number is more than the other number. So the larger number, x, is 15 more than, remember that always comes after, more than what? Well, it's got to be more than the smaller number, which is y. So x equals y plus 15. All right, now the second sentence gives us our other equation. The sum of twice the larger number and 3 times the smaller is 185. There's our equal sign. Let's go back. The sum, that's going to be plus, twice, that's going to be times 2. Twice the larger, what represents the larger? X. So twice the larger, 2x. Now the sum plus and 3 times the smaller. So 3 times the smaller is 3y is 185. So let's go back and read that again. The sum of twice the larger, 2x, and 3 times the smaller, 3y, so we're adding those together, is 185. Now again here, what method do you want to use to solve it? As I look at this, I say this is set up nicely for substitution. As we look at that first one, what do we see? Well, hey, we have x isolated. Where's x in the other one? What are we going to do? We're going to substitute in y plus 15. So as we go ahead and do that, we get 2 times y plus 15 plus 3y equals 185. So now as I look at that equation, I'm feeling good because I see I only have the variable y in there. So now I'm going to remove grouping symbols using the distributive property. 2y plus 30 plus 3y equals 185. Now I'm going to combine like terms. That's my 2y and 3y. 5y plus 30 equals 185. Now I'm going to use my inverse operations. So the inverse of adding 30 is to subtract 30. 5y equals 155. And then the inverse of multiplying is to divide. So 5 times y, the division there is divided by 5. So we have 155 divided by 5, which is 31. Now, I'm not done yet. I've only solved the first part of it, but very simply I say x equals y, which is 31 plus 15, and x equals 46. So, the larger number is 46, and the smaller number is 31. Okay. Now I'm going to push pause, and I'm going to come back and finish these other ones in a little bit. Okay, gang, I'm back. Moving on to number 3 here. As we read this, Camp Nazareth ordered a total of 100 frisbees and basketballs for the summer camp. Frisbees cost $4.50 each, and basketballs cost $20 each. The total purchase was $822. How many of each item was ordered? So we've got frisbees and we've got basketballs. Okay. Frisbees, basketballs. So we got to make some variables here. So let's let f equal number of frisbees. And let's let b equal the number of basketballs. If you want to use x and y, you can do that. You know, that's not a big part of it. Now we have to translate. Well, they order a total of 100. So together here, if we do the number of frisbees plus the number of basketballs, that has to equal 100. Now, we know the total cost was $8.22. Frisbees cost $4.50 each. Basketballs cost $20 each. So if I do 4.5 times the number of frisbees plus 20 times the number of basketballs, that's got to equal 822. Now I just eliminated the decimals. You can do what you like with that. At that point, you don't have to necessarily keep those there, but you can as you will. All right, so the question that we now have is, what method are we going to use? Well, as I look at this, to me this looks like it's set up nicely for elimination, because I've got the frisbees over the top of themselves, F there, and I've got B over the top of itself. But we definitely don't have coefficients that are opposites, the same but opposite. So I'm going to go ahead and I'm going to solve first for frisbees. And to do that, I'm going to multiply the top one by negative 4.5. That'll give me, this times 1 will give me opposites, and I can cancel those out. So I'm going to get negative 4.5 F minus, now we've got to distribute to everything, 4.5 B equals, and don't forget to distribute it all the way over here to the other side. And when you multiply it by 100, we get negative 450. Now the bottom one, that can stay the same, or if you want to multiply it by 1, that works for me. 4.5F plus 20B equals 822. So remember, first we have to manipulate the coefficients to be the same but opposite. We've done that. Now we can add together to eliminate. Those two are going to add to be 0. And then we've got negative 4.5 plus 20 here, which comes out to be 15.5b equals, and then we've got negative 450 plus 822, 372. So now we're going to divide that by 15.5. Divide it by 15.5. So divided by 15.5, 24. Now this is an instance where you're talking about the number of basketballs. So you really want that to come out to be a whole number. You wouldn't want half of a basketball. I'm going to go back to my original equation. Well, it's frisbees plus the number of basketballs equals 100. So we subtract 24, and we get frisbees are going to be 100 minus 24, which is 76. So they're going to have 24 basketballs, and they've got 76 frisbees. So they're probably playing some frisbee golf, something like that. Okay? So we're going to do one more money one, and then I'm going to let you do a couple more. Let's do number 5. 3 bags of potatoes and 4 coarse cases of corn costs $40. 5 bags of potatoes and 2 cases of corn costs $34. Find the cost of 1 bag of potatoes and the cost of 1 case of corn. So we want to find the cost of the potatoes and the cost of the corn. So that's going to give us our let statement. So let's let P equal cost of bag of potatoes. And let's let C equal the cost of a case of corn. All right, so now we've got our let statements. That's the first part. Now we want to translate. So we go, look, 3 bags of potatoes. So 3P plus 4C equals $40. 5 bags of potatoes and 2 cases of corn. So 5 potatoes plus 2 corn equal $34. Now we need to solve for C and for P. All right, so again, this to me looks like it's set up nicely for elimination. As I'm looking here at my coefficients, things are lined up. That's kind of an elimination setup. We could use substitution, but we got a little more work to do if we're going to do substitution. So which one do we want to eliminate? Now, there isn't a wrong one to eliminate, but to me, I see 3 and 5, and I see 4 and 2. I like 4 and 2 because 4 and 2, they've got a common multiple of 4. Okay, 2 plus 2 is 4, so that's going to get me. So I can leave the top one the same. Now remember, we want the coefficient to be opposite, so I'm going to multiply the bottom one by -2. So the top one is just going to become 3p plus 4c equals 40. No change there. But on the bottom one, I'm going to multiply by a negative. Now every sign is going to change. So that's going to be -10p minus 4c equals, and then -2 times 34 is -68. So we've done some multiplication to get opposite coefficients, which means they're going to eliminate. Let's add 3p plus -10p, gives us -7p, and 40 plus -68 gives us -28. So now if we divide by -7, we get p equals 4. So that is going to be the cost of one bag. It's going to be $4 for a bag of potatoes. Now we got to find the case of corn. Again, this one, it doesn't really matter which one you choose. Just pick one. 3 times 4 plus 4c equals 40. 3 times 4 is 12 plus 4c equals 40. So we want to subtract 12. 40 minus 12 is 28 divided by 4. And that's going to be $7. So the potato bag cost $4, and the corn case cost $7. So we got the potato bag, we got the corn bag, we found the cost there. So hopefully that's helpful for you, and you got 2 more that you can work on there on your own to get a little bit of extra practice with solving system word problems there. All right, goodbye.